Everyone, welcome back to the Comptia Network Plus course. Scada, Systems, Industrial Control Systems. Industrial Control System, ICS, is a general term that encompasses several types of control systems used in industrial production. The most widespread is Supervisory Control and Data Acquisition, Scada. Scada is a system operating with coded signals over communication channels to provide control of remote equipment. It includes the following components: sensors, which typically have digital or analog I/O, and these signals are not in a form that can be easily communicated over long distances. Remote terminal units, RTUs, which connect to the sensor and convert sensor data to digital data, includes telemetry hardware. Programmable logic controllers, which connect to the sensors and convert sensor data to digital data, does not include telemetry hardware. Telemetry systems, which connect RTUs and PLCs to control centers and the enterprise. Human interface, which presents data to the operator. ICS server, also called a data acquisition server, which uses coded signals over communication channels to acquire information about the status of the remote equipment for display or for recording functions. Medianets. Medianets are networks primarily devoted to voice over IP and video data that often require segmentation from the rest of the network at some layer. We implement segmentation for two reasons. First, to ensure the security of the data, and second, to ensure that the network delivers the high performance and low latency required by these applications. One such high demand application is video teleconferencing, VTC, which I'll cover next. Video teleconferencing, VTC. IP video has ushered in a new age of remote collaboration. This has saved a great deal of money on travel expenses and enabled more efficient use of time. When you're implementing IP video systems, consider the plan of the following issues. Expect a large increase in the need for bandwidth. QoS will need to be configured to ensure performance. Storage will need to be provisioned for the camera recordings. Initial costs may be high. There are two types of VTC systems. Let's take a look at each. ISDN. The first VTC systems were ISDN based. These systems were based on a standard called H320, while the bandwidth in each ISDN line is quite low by today's standard. 128 kilobytes per line. Multiple lines could be combined and bonded. IPSIP. VTC systems based on use a standard called H323. Since these work on a packet switch network, you don't need a direct ISDN link between these sites. Session initiation protocol can also be used, and it operates over IP but lacks many of the structured call functions that H323 provides. Legacy systems. Legacy systems are those that are older and incompatible with modern systems and equipment. They also may be less secure and no longer supported by the vendor. In some cases, these legacy systems, especially with respect to industrial control systems, use proprietary protocols that prevent them from communicating on the IP-based network. It's a good idea to segment these systems to protect them from security issues they aren't equipped to handle, or even just to allow them to function correctly. Separate private public networks. Public IP addressing isn't typically used in a modern network. Instead, private IP addresses are used, and network address translation services are employed to convert traffic to a public IP address when the traffic enters the internet. While this is one of the strategies used to conserve the public IP address space, it also served to segment the private network from the public network internet. Hiding the actual IP address private of the hosts inside the network makes it very difficult to make an unsolicited connection to a system on the inside of the network from the outside. Honeypot, Honeynet. Another segmentation tactic is to create honeypots and honeynets. Honeypots are systems strategically configured to be attractive to hackers and to lure them into spending enough time attacking them while information is gathered about the attack. In some cases, the entire network called honeynets are attractively configured for this purpose. You need to make sure that either of these types of systems do not provide direct connections to any important systems. Their ultimate purpose is to divert attention from valuable resources and to gather as much information about an attack as possible. A tar pit is a type of honeypot designed to provide a very slow connection to the hacker so that the attack takes enough time to be properly analyzed. Testing labs are used for many purposes. Sometimes they're created as an environment for developers to test applications. They may also be used to test operating system patches and antivirus updates. These environments may be virtual environments. Virtualization works very well for testing labs because it makes it easier to ensure that the virtual networks have no physical connection to the rest of the network, providing necessary segmentation. Security. One of the biggest reasons for implementing segmentation is for security purposes. At layer 1, this means complete physical separation. However, if you don't want to go with complete segmentation, you can also segment at layer 2 on switches by implementing VLANs and port security. This can prevent connections between systems that are connected to the same switch. They can also be used to organize users into common networks regardless of their physical location. If segmentation at layer 3 is required, it's achieved using access control lists on routers to control access from one subnet to another or from one VLAN to another. Firewalls can implement these type of access lists as well. Compliance. Finally, network segmentation may be required to comply with an industry regulation. For example, while it's not strictly required, the Payment Card Industry Data Security Standard PCI DSS strongly recommends that the credit card network should be segmented from the regular network. If you choose not to do this, your entire network must be compliant with all sections of the standard network optimization. Regardless of how well a network is functioning, you should never stop trying to optimize its performance. This is especially true when latency sensitive applications such as VoIP, streaming video and web conferencing are implemented. In the next several sections, I'll discuss some techniques you can use to ensure that these applications and services deliver on their promise of increased functionality. I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.